I'm excited to talk today about both Telegraphy and Apache Pulsar. I've been working with Pulsar for a little over a year, mostly at the previous company I worked at, and then now with a pretty ambitious side project I'm working on. And so, yeah, I wanted to kind of show how something historical like the Telegraph kind of contributes to what we're designing today as far as a distributed pub sub system. So as far as an agenda goes, first I'm going to talk about myself, introduce myself, I guess, not for very long because that's the most boring part of this talk. And then talk a little bit about history with the electric telegraph or wireless telegraph. Then talk about Pulsar, some of the internal design considerations there, why those decisions were made and kind of what value that those bring, how I've used Pulsar and how others use Pulsar as well, and talk about the future of Pulsar. And if I have time, I have a demo that I will also show Pulsar working. I ran through this a couple times before, and depending on how fast I speak, sometimes I have time, sometimes I don't. So if you're interested in the demo, if I don't get to it, happy to show it to you. It's mostly in jest, so it's nothing too crazy if you're not if you're worried about missing out on it. And then at the end, I'll take questions if I have time as well. If I don't, then feel free to either catch me on Twitter, I'm on there a lot, or email. I'll provide those details at the end if you would like to do that. So this is a much better picture of me than any picture I could take with a camera. And I'm a software engineer at Pluralsight. Out of curiosity, how many people here have used or heard of Pluralsight? Great. Before I worked at Pluralsight, I worked at a company no one ever heard of, so it's always embarrassing whenever I come speak at conferences, because then I have to try to explain what the company did. And if you ever explain what your company does, even something like Pluralsight, it's not a good time, especially when it's like a non-technical audience and you work on data infrastructure. It's usually bad time. I live in Salt Lake City, and Pluralsight's headquartered there. It's a very not diverse place, but that's okay. There's some other good things about it, like the low cost of living and snowboarding if you like that, which I don't. But there's a growing tech sector there. So Pluralsight went public last year. We had 3 or 4 other tech companies over the last couple years. So it's a decent place to live. I may not look like it, but I do cycle. So road biking. I used to be 50 pounds lighter, but I'm getting back into it, trying to get back into what I call Speedo shape, and we'll see if I can get there. And then I got into model rocketry this year with the 50th anniversary of the Apollo moon landing, and that's been great. I got burned a couple times. It's a good time to get into model rocketry. All right, so with that, I'll get into the kind of weed guts of my talk. So I think there have been a couple talks that I've attended today that have said this, but the history of computing and of communication in general is probably an under-examined field in our industry. And there's a lot that we can kind of learn from looking back into the past, and you're trying to hearken lessons from that. And in this case, as I worked with Pulsar, I started reading this book. It's called The Victorian Internet, and it's basically a history of telegraphy. So from kind of the earliest incarnations of it to the latest before it kind of retired. And actually, you could send telegraphs up until 10 years ago. It's kind of stuck around for a really long time. And in reading this book and actually kind of looking at the title, it strikes me as pretty interesting that the author referred to it as the Victorian Internet. And it really did suffice to kind of be that during its heyday. So people would send the equivalent of SMS or text messages through that. And I'll kind of talk about some more usages in a second, but it was in an era where people wore really ugly clothes had really bland food. They were able to kind of come up with something technologically that was really interesting. And there are a lot of lessons that we can kind of learn from this technology. So here's kind of I guess a vector artist rendering of a telegraph. So I guess to be kind of pedantic, there's sort of several ways that you can do telegraphy. So there's one, the kind of the more well-known is that you can actually just send plain text. So you can just kind of write a note, and then that can get passed on. And then the second way, which is probably the more common way people think about it, is through Morse code, which I'll get into in a second. So one of the, I guess, the downsides of using one of these systems is the transmission costs. So this is like a switchboard. So if you were sending a telegraph to me and you lived one part of the network and I lived another part of the network, this kind of switching would happen. So you basically would send it to one of these switchboards and then they would route it to me. And so you can see kind of quickly that while that is somewhat efficient, there's also a few holes in that that way of sending data. So number one, like any of these nice people here, sending them could read your message. So if you had something private that you wanted to say, which a lot of people did. So one of the things that was covered in that Victorian Internet book is that early editions of online dating, so like your Victorian era Tinder, happened through this. So people would send somewhat explicit messages through these services, and some of these switch operators would just kind of read them and get a chuckle out of them because they knew it was like going from point A to point B, and all their messages are just kind of explicit, so they'd kind of read through it. And even more than that, so another thing you can always kind of expect with new communication mechanisms is organized crime. So organized crime rings liked telegraphs because they could be on separate sides of the country and kind of organize their activities. If you've ever seen the television show The Wire on HBO, they use cell phones for this. They call them burners, and they used to kind of transact on all their drug deals. But in the Victorian era, this sort of the way that you would do this. And yeah, this is just people that are making moonshine. So that was also a good time. So one way to kind of get around people reading your messages is to create a cipher. So that would essentially be like encryption, so that only the person sending it kind of encrypts the message, and then the person receiving it knows how to decrypt it. And so during the kind of popularity of telegraphy, these kinds of books that would be explaining how to decipher and to encode and decode messages were relatively common. And the problem with it is that when you only have like characters, like text to use, you can kind of do like Pig Latin or some other variation and try to translate it, but they're pretty easy to figure out. So some of the organized crime mobs of the time would make ciphers, and then the government would figure it out and then figure out where people were meeting and kind of bust them that way. So this is not ideal either. But at the kind of height of telegraphy, this was the for at least this one company, their service map. So if you wanted to, you can send a message from anywhere, and so the furthest west to the furthest east, or furthest north to furthest south. But if you're sending a message, you might hit several switch operators in doing that. And also what you will notice about that is not only the privacy issue, but also there can be message quality issues because someone has to pass that along, and they could kind of distort the message in doing that. So I guess the more famous, usages of telegraphs were these tape messages. So if you think about something like the New York Stock Exchange, it's essentially like a never-ending sort of ticker of data. And the first kind of renditions of this were with the telegraph. So you could, at the beginning of the day in New York, start tracking all the stocks for the different companies and send that on the telegraph. And then all the subscribers downstream across the country could know what the price of those stocks were throughout the day. So it was a pretty powerful medium. Also, breaking news, the way that you get on Twitter came through this mechanism as well. So you could find out who won the presidency, for example, or you could find out, I don't know, people were doing back then. People were owning slaves, I guess, was one of the things they were doing. But you know, that's all things that how people were communicating. And I guess another example I've written down in my notes here is like meeting minutes. So if you had like a U.S. geographically distributed company, or actually if you had one in like London and you had a company in Europe, because there were some transcontinental networks as well, you can send meeting notes across. It'd be kind of an expensive thing to do, but it was possible. So this is an example of kind of a late era telegraph, and this is one that used Morse code. So I'll just kind of show what Morse code looked like. So it's just a way to express language in dots, essentially. So you could translate a letter or some other longer text into these dots, and then you can communicate wirelessly over radio instead of with the wired network like the original telegraph. So this enabled kind of solved some of the problems that were with the wired telegraph, but kind of introduced a whole new slew of problems as well. So we can talk about kind of these problems, and then I'm going to use this as a jumping board to switch over to Pulsar and talk about how Pulsar is sort of similar to this, and then how it addresses these specific problems. So data storage. So if you were to think about receiving a telegraph, and you didn't write it down, for example, and then you wanted to like replay every telegraph that you had in the past for whatever reason, there's going to be some issues with that. Or if you wanted to collect other telegraphs that people were sending, there might be issues with that as well. So data transmission. So if there are any problems in the network, that would be hard to receive messages. And there were some other issues around deciphering. So if you want to ensure that your data is secure, kind of going through the wire, it's pretty hard to do in the telegraph age. Multicasting is also difficult. So if you had several subscribers that you wanted to send messages to in the wired telegraph age, that required having physical switchboards kind of connect you, and then in the wireless telegraph age, it required, since it's a radio frequency, to kind of knowing the radio frequency of what you're subscribing to. Encryption, we kind of talked about, and then delivery guarantees. So in the wireless telegraph network, there's pretty much no guarantees, and then in the wired one, there was at least once guarantee. So they would try to resend your message if you called and complained and said that you didn't receive it. So you could get it, or you could get it twice if like they didn't think that they sent it to you as well. So with computers, which we have now in our beautiful age, how can we use those to kind of enhance what telegraphy promised us and kind of fix the problems therein, is what I'm going to talk about next. So Apache Pulsar is part of the Apache Software Foundation. It came out of Yahoo, and it's a distributed pub/sub system that's focused on a few things. So one of the things that it is focused on is being globally distributed. So if you have data centers across the world and you're trying to have kind of a unified looking publish subscribe system, that's what Pulsar is designed to do. It's also, I'm going to get into in a second a couple of the design considerations and how those solve that list of problems. But it's got a reasonable logo. I work with a lot of Apache projects for my job, and a lot of the logos are bad, but I think this one's okay. It definitely looks like it's designed by a back-end engineer, but it's okay. It's not, we can work with it. So let's talk a little bit about the sort of basic architecture of Pulsar. Oh, okay. So we'll talk about the basic architecture of Pulsar. So Pulsar consists mainly, if you look at on the bottom here, at the Pulsar nodes. These are brokers that as a user connecting to Pulsar, this is the interaction point that you would have, sort of the client experience that you would connect to the nodes. And then it has a second component, which is called Bookkeeper. And Bookkeeper is how Pulsar stores its data. So this is a pretty unique approach in terms of publicly subscribed systems. Usually the data is stored on the nodes themselves. Pulsar intentionally stores them separately, and I'll get into why in a second. And then in the top here, it has this thing called Zookeeper, which is essentially to help coordinate all of this. So because this is distributed, there's a lot of failure modes with distributed software and a lot of problems that arise. And Zookeeper is essentially there to help understand the state of the cluster at any point so that you can make decisions. And I'll get into those architecture decisions and kind of what those ramifications are in a second. Okay, so let's review our problems. So we're going to talk data storage, transmission, multicasting, encryption, delivery guarantees, and so we'll start with data storage. So in general, so like in the wireless telegraphy case, we kind of talked about what the limitations of storage would be in that case. Like there's no database of your telegraphs. There's no way to keep a distinct order of when you receive them if you wanted to replay them. So for example, if you're trying to tell a story about something, like if you were in court and you said, I think this person committed this crime because I have this telegraph, I have these several telegraphs, and I want to use them to make this person seem guilty. You have to kind of stitch that story back together, and there's not like a logical ordering per se. So the first thing that Pulsar is, which also Kafka does this as well if you use them, is an immutable log. So essentially every message that gets written to a log that has some ordering guarantees, and then also has some specifics about how data is written out of that. So as far as the storage architecture, I talked about this a second ago. Most systems that try to do this will keep the storage and the brokers that communicate with clients together. So an architecture that kind of looks like this, where you have up to n brokers and some kind of communication mechanism between them, and then you have storage on each of those n brokers. And so with this architecture, there are some limitations to this. So as far as the storage goes, since it's coupled with your nodes, then so if you have any problems that are like unrelated to storage, or you had node problems, so if you had node problems that are unrelated to storage, or storage problems that are unrelated to your nodes, it's going to be a similar problem. And so if you want to scale up storage, that also means scaling up nodes. So Pulsar instead takes this approach. So you can scale up your nodes and your storage separately. So if you have really expensive messages, for example, so like the payloads that you receive are large, then maybe you want to scale up your storage, but maybe the volume isn't as big. So you can keep maybe the volume of messages, so like how many messages you're getting isn't as large, so you can keep that much smaller. So that's kind of mostly the approach of Pulsar, and Bookkeeper is used in other systems. So Bookkeeper is used in Hadoop, and you'll see it around. It's also used in another distributed PubSub system called, I can't quite remember the name of it, but another great feature of Pulsar is because the storage is separated from the nodes, then that you can do interesting things with the storage. So Pulsar has this thing called tiered storage, and essentially is if you think about Bookkeeper as kind of the hot storage, like what happens in exactly now. So all the data that is being written to your nodes are in there. But as the data gets older, Pulsar can actually automatically archive that to a different system, like S3, which is much cheaper to store than on disks that you need to kind of keep live in a bookkeeper cluster. And then even more so, it can push that into Glacier, which is an even slower storage mechanism. But the interesting thing about this is that despite having 3 different storage mechanisms, if you were, as a client, wanting to read older data from Pulsar, the API would still be the same. So in this case, like if you had data in a topic that went all the way back to like years and it was in Glacier and you said, hey, give me all the data from this topic, it will do it, and it will just kind of manage the connecting to S3 and connecting to Glacier. So this is something that I actually did a lot at the previous company I worked at. We had several petabytes of data, and we generated several terabytes per month. And so keeping it all in Bookkeeper was too much. And so having this API and this kind of storage layer, it was much better. So it's a flexible way to kind of manage the storage of messages, which Telegraphy didn't really have. Most of the storage mechanism was putting those receipts of the telegraph into a filing cabinet, maybe in some kind of monotonic order or something like that. Okay, so we solved that problem. Next, we're going to talk about data transmission. So data transmission, so how data gets into Pulsar and out of Pulsar is pretty important, and how it differs from the telegraph is something I'll describe as well. So Pulsar's main mechanism of controlling data is through a schema registry. So Apache Kafka has a similar concept. It's basically a contract that says, if you're sending data to this topic, it's going to look like this. It's going to have this schema. So every message that gets written to Pulsar gets checked against a schema registry, and then it gets written to Bookkeeper if it passes that check. So in this case, in this example, it just has like 2 arbitrary fields, and so every message that gets sent from a client to any one of the nodes would get checked against the schema registry. And the most common way to encode data into Pulsar would be through Avro. So you can do Avro or JSON schema, but Avro is way more common. How many people here have used Avro, out of curiosity? Okay, so it's pretty well known. Basic Avro schema kind of looks like this. So you have a namespace and then some fields. And one of the reasons why you would use Avro over another mechanism is because of schema evolution. So for example, if you, in this case, what we're saying is explicitly every message that's ID, or every message has an ID field and a username field, and the ID field is an int type, and the username field is a string type. But if you were to get null data, it wouldn't really handle that well. And so, or actually wouldn't write it at all in the Pulsar case. And so you can evolve your schema, which basically, in this case, like we're going to say that usernames are allowed to be null. So this would effectively make it so that any new data is still conformant to that schema. And so essentially makes it so that you can think about your schema as not so static, which could be pretty detrimental in a message passing case when there are lots of different uses that you can see in the future. But with some slight tweaks, you can get kind of more mileage out of it. Okay, so we handled those 2. Multicasting, excuse me. So multicasting essentially is if you want to communicate to multiple consumers the same message. So in this case, like the red circle wants to send the same message to several green circles, but not the yellow ones, because they're not subscribers. And so in our, I guess, modern world, there's a lot of reasons to send these kinds of multicasted messages, like multiple people on a group text chain, for example, which I think everyone dislikes group text. I definitely do. I've never had a good experience. Or Slack, something like that, or to manage kind of the multiple needs of different consumers, which this drawing is supposed to kind of illustrate. So as far as how Pulsar handles this is a little bit smaller, I apologize. This is borrowed from Pulsar's docs. Essentially, if you're a producer, so you're someone sending data to a topic, multiple producers can send data to the same topic, and then that topic can have subscriptions, and then each consumer can subscribe to one or multiple topics essentially. So that's the way that Apache Kafka handles it, and other systems like this as well. But in the case of telegraphy, they didn't have a way to do this kind of multicasting that easily. But in our modern age with computers, we can do it much better. Okay, so that multicast is not crossed out. QA on my slides. Okay, so as far as encryption goes, if you're sending messages from a client to Pulsar and then people are consuming those messages on the other side, encrypting that data would be of value. So out of the box, Pulsar supports this regular SSL. So this is just kind of a little description of how, or a little example of how that works. Pulsar also has some other security mechanisms as well if you want to enable those. I haven't actually used anything besides SSL because it works so simply. And this way, you won't have the same problem as the gangsters, I guess, trying to send their messages in the telegraph world. You can send them through Pulsar, although the NSA might be able to intercept them still. So that's for another day, I guess. So delivery guarantees. So when you are a client and you send a message to Pulsar and it's acknowledged, what kind of guarantees can you expect? In the telegraph case, they weren't very strong guarantees. So it was just kind of this no guarantee situation where you could send multiple messages as a client, and then there's no real guarantee that the party downstream would send it. Actually, in the Victorian Internet book, in the early days of telegraphy, people would send like a telegraph and a letter because they would kind of expect that there was some non-zero chance that it just wouldn't get to wherever they were sending it. So yeah, that's kind of embarrassing. So so then the kind of doing a little bit better is the at most one. So you'll try to send it, and it may be received, may not be received, but you're not going to try to send it again. And then the at least once would be you're going to try to guarantee that it's sent, but that might mean that you're going to send the same message multiple times. And then exactly once, which when I was coming up with this illustration, it's kind of funny because the iPhone definitely doesn't do this. So I receive multiple messages a lot of times, but the concept is that you can kind of guarantee that if you have a message and it's acknowledged from the Pulsar consumer, the Pulsar node, then it's only going to be in there one time and not multiple times. So Pulsar actually supports both of these semantics, so at least once and exactly once. It just depends on how much latency that you want to add to the overall system. So in order to get that kind of exactly once guarantee, there's just going to need to be a lot more acknowledgements. Whereas in the at least once, you don't have to have as many, and so you might have to have a case where multiple messages get pushed through. All right. So with the last few minutes I have, I wanted to talk about stream processing. So once you have data in Pulsar, what you can do with it from that point onward. So one of the main ways that you can do stream processing in Pulsar is with Pulsar Sequel. So Pulsar, because the whole architecture is designed to be pluggable or kind of like Legos, and you can add pieces to it as you need. Pulsar Sequel is essentially adding an embedded Presto, Presto is this distributed SQL on anything query engine. So essentially adding an embedded Presto to your Pulsar architecture, and then that enables you to do SQL on top of your topics. So effectively, you just send the SQL queries, and then Presto will just kind of handle that. And this actually will work even in the case where your data is in S3. Some of it's in S3, some of it's in Glacier. So this API will just kind of SQL over the whole thing. So make a query plan that would manage it. So in Pulsar's case, the data and kind of where it's stored is included in the metadata of each message. So as far as Presto is concerned, it can kind of stitch together like an intelligent enough query plan to do that. And this is from the Pulsar docs, so this is a little bit more sort of insight into that kind of Presto worker and Presto embedded Presto engine. So effectively, no matter what data you've got, so if you think about this, this is like a real-time data coming in, and you also have data that's stored across multiple engines. So if you did like a select star, for example, then you would need to get all data through history and then also keep tailing the new data. And yeah, that's exactly the way that Presto's designed to manage that. So alternatively, Pulsar has Pulsar Functions. So Pulsar Functions are a serverless function implementation that runs on the Pulsar nodes themselves. So the key things to consider with Pulsar Functions are that at the moment, they only have one input, one output, so they can only consume from a Pulsar topic, and then they write out to one or more Pulsar topics. So I'll get into this in a second, but like when we were using it, we wanted to have some more advanced usages where we would like go out into other things, but at the moment, this is kind of the usage. So to kind of reiterate that, this is an illustration. So it's kind of hard to see, but there's like a little FN on the Pulsar nodes. So the functions actually run on those nodes. And probably some of you are thinking, okay, well, that might be like a resource issue. So like Pulsar is supposed to be trying to manage the connections and like keep everything acknowledged, keep ordering across the topics. Like how is it also running these functions? Like what available space is there to do that? And Pulsar is also JVM, so even more so. Like how is it doing that? So effectively, in the kind of the naive approach, it's just running, taking resources up in its own sort of namespace. But if you wanted to add more isolation, in more recent editions of Pulsar, you can actually run those in Docker if you want. And then I failed to mention that Pulsar functions, you can write them in Java, you can write them in Python, and with the most recent release of Pulsar, you can also write them in Go if you would like. And then those will essentially consume messages from a topic and then push them to another topic. This is a Go example from the docs, or it's actually from the repository. There's a big example in there. So you don't need tons of code. So all this is doing is pulling in the Pulsar Go client and then connecting to this my topic and then doing a loop and writing a hello with a counter attached to it and writing that to another topic. So okay, so as far as the future is concerned, what I look forward to with Pulsar. So this is something that I am pretty excited about and trying to work on as well, is the ability for Pulsar functions to have syncs outside of Pulsar. So if I wanted to use my Pulsar function to write data to Elasticsearch or CockroachDB or like Google File System or whatever, that I would be able to do that. So right now you can't. So effectively you would have to write to another topic and then have another process that did this. But that would simplify things quite a bit to allow that. And then as far as things I'd like to try in the future as well, so this is in the Java land, but since Pulsar functions are either just Java, just Go, or just Python, and they're just, in the Java case, it's a jar, in the Go case, it's a binary, and Python case, it's just a Python file, you can import libraries and do all sorts of interesting things. So in my case, I'd be interested in trying machine learning or doing some better regex, because a lot of the topics will have malformed data, and being able to kind of clean those up, pass them on to another topic is something that we're looking forward to doing. So I do have a few minutes, so I'm going to go ahead and try to do this demo real quick. So I'm gonna move this. Oh, that totally didn't work. Okay, so this is Streamlio. So Streamlio is a company that runs managed Apache Pulsar, and they have a managed demo that you can do. So if you want to just try Pulsar, this is one of the better places to try it because you don't have to deal with all of the architecture and hardware that it would take to run it. So at the moment, I have a few topics. I've got one Pulsar function, and then I've got one source. So the source I have is this. Actually, can't see that too well, but it's writing data to this RSS topic, which I can come in here and take a look at that. So if we look at the schema, actually, that's probably harder to see. We'll do this. Okay, so the data that's getting written to this looks roughly like this. It's a bunch of address, name, and other personal artifact data. So what I'm gonna do is create a Pulsar function that, we'll look at the code. So all this Pulsar function does is take the input, which is each of those JSON blobs, and then I'm ripping out first name, last name, and social security number. And this is what I'm calling my NSA topic. So I'm effectively just ripping that data out and then publishing that data to a new topic. So if we come back to topics and look at NSA topic, and then look at one of these partitions, yeah, we can see that I just basically took the first name, the last name, and the social security number there. And I'm just printing this topic for some nefarious cause later. So, okay. So if you want to try Pulsar, you can check out the docs. You could try it locally by pulling it down on Docker or with Docker Compose. Or you could try a free trial of Streamlio if you want. I do not work for Streamlio. I'm friends with them, but it's a pretty good way to use Pulsar. And then if you have any questions, I'm out of time, but you can stop me. I'll be around. I'm pretty easy to find. I usually have some kind of like bright shirt or like flowers. So, but thank you for coming to my talk. It was a pleasure speaking.